Right now, there are 8.3 billion people on Earth. Every text that they write, every email that they type, every word that they speak, all of it adds up. And for around 100,000 years, there was a monopoly of a single species on a language, we humans. But that monopoly is now on the verge of being broke up. Next month, in June 2026, that monopoly ends officially. What will happen is the amount of words that AI models from all of the frontier labs combined generated will far exceed the amount of words that we humans speak and consume in a day in any form. And things will not just stop there. By January 2027, words generated by an AI model from any single frontier lab will be far more than the words that we humans generate in a single day and consume in different forms. It is being done by a technology that was non-existent around 3 or 4 years ago, and it is about to outtalk humanity itself, from which it learned those things. And the speed at which this intelligence is upgrading is breaking everything we thought we knew and had our monopoly over it. We used to wait years for a new model. Recently, we saw category defining models like Mythos and OpenAI's Spud drop within just few days of each other. Rumors are that OpenAI is again dropping a newer GPT 5.6 models next week. These timelines aren't just shrinking, they are in a way just collapsing in a very exponential, astronomical way. But here is the secret: the industry is just quietly realizing this intense speed isn't just happening because we are scaling up more data, more compute, more resources. No, that era of brute forcing AI to make it more smarter, intelligent, well, that is dying. Today, I will talk about the mathematical wall we just hit, the extreme physical limits breaking our energy grids, and what happens to you and me when the tools we use to think start upgrading every few weeks. The time before we learn to use them, well, there's a new tool that is completely different from the previous one. That's how faster those upgrades are gonna happen. For the past 3 years, the AI industry operated on a very beautifully simple rule: bigger is better. It was called a scaling laws. And by bigger I meant compute training data, not what you think. Coming on the topic, if you wanted a smarter AI, you didn't need to invent a new brilliant algorithm. You just needed a bigger engine. You increase the size of the neural network and give it more computer to run it on, and fed it entire internet data. Well, it was a guarantee that you will be getting a more smarter model than previous ones. It was like, imagine you are building a skyscraper. The law was telling you that if you want it to go higher, just buy more bricks, employ more people, and you can simply brute force it. But there is another dirty secret that comes with scaling laws. They are incredibly unforgiving. The gains you get from throwing more computers at a model are not just a straight line curve like we expect. They are a curve that flattens out over time. The more resources you throw, the more inefficient it gets at the end, and as time passes, it even reaches the limits where to make a model more smarter further, you have to increase its resources exponentially. The math is just brutal. For an 8 times increase in model size, you need a 5 times increase in training data just to avoid a penalty in performance called total loss. When your model is smaller, finding 5 times more data and unique data is easy. But when your model has already studied all of the internet data, from books to literatures, everything that has existed there, including YouTube videos, well, you just hit a wall. And it's not just a data wall, it is a physics wall. It is not possible to get the next massive leap in intelligence using that old brute force method. You don't just need a bigger server room, you need a dedicated power plant also. Right now, the power consumption of individual server racks size of a fridge is also skyrocketing. Between 2020 and 2025 it increased over 11 times. By next year it will quadruple again. Standard electricity grids in nations like US cannot handle it. For US, it's another difficulty that they face is in the supplying of the infrastructure that is needed for grid like transformers, which US depend on just a few suppliers which are mainly based in China. Data centers in US are now desperately pivoting to other methods like natural gas electricity generators, all built in the plant, and AI companies are also heavily investing in small nuclear reactors, and that is just for inference to keep them running. For training those more powerful bigger models we need much more electricity than that if not possible. If a new breakthrough in electricity will not be made in next few years, then the electricity will be much more scarce than we think now. The ultimate bottleneck of AI won't be math or biology, it will be electricity and energy. Intelligence when done artificially is very expensive, so AI models are already running out of internet and electricity to power those god AGI level models. How did we just get a massive avalanche of new hyper capable models that we have never seen before, all trained from scratch and just in a single month? Because the smartest engineers on earth realized that to keep going, they had to stop building the skyscraper. What they had to do was start building a swarm of small buildings, all connected underground via tunnel network that can work more efficiently, house more people, and do things that the skyscraper cannot in a safer, efficient way. And what we are seeing right now is a shift from that brute force strategy to hyper efficiency based strategy. Instead of taking an old massive model and trying to make it fatter, labs are doing two things. First, they are training smaller models which are being trained entirely from scratch using perfectly curated synthetic data which is generated by using different AI models. And the second strategy which they are taking is optimizing for test time compute. Instead of spending the same amount of energy and compute power answering hello, the models now smartly understand how difficult the question is and how much they need to think before answering that question. The AI can now actively scale its computational power while it formulates an answer. It can double check its own work, and that has worked effectively in making the AI models far more efficient. And that problem that Sam Altman tweeted, which were please and thank you for causing AI companies loss in billions of dollars. Well, that problem has now been solved. The AI models now cost similar to what a general Google search costs, and they only consume less than 1% of the power if all of the search that we do today were done by AI models. And it was done by using test time compute. And this brings us to the next inevitable step. Right now, when an AI reasons through a problem, it has to output its answer in English or whatever language you prefer. But compressing complex high-dimensional mathematics into human words is incredibly slow and inefficient. First, a large amount of computer resource goes into that, and a large amount of training data is needed to further enhance the capability of models to reason well and think through. The next breakthrough that will solve this problem, and companies are already working on it, is called latent reasoning. In the near future, The models won't be thinking in words, but compressing complex high-dimensional mathematics into human words. They will take your prompt, loop it through thousands of thoughts simultaneously in all the directions, unlike now where they work in just a single direction of thoughts and only translate back into English the final answer that they think is the most accurate. They will still use prediction algorithms, which leaves us with the most important question. If we are moving into a world where AI swarm can train itself, adapts its own computing power, and think in a mathematical language we cannot even comprehend, what exactly is the role of a human being? Very soon, the AI will be able to do a 40-hour human task in a few minutes. We can already see in METR graphs that the time for which an AI model can work autonomously is continuously accelerating. The methods just performed for 17 hours without any breaks, beating Gemini 3.1 Pro, which was released around 2 months back, I think, which worked at around 12 hours. And the things are just getting much longer. So if you are someone who just purely generates, so if your only skill is writing an basic article or coding a standard function, you are competing against a machine that upgrades itself every few weeks. But for AI, for all of the latent reasoning tech and other things to come true, the AI still needs a prompt. It still needs a direction, and that's where I think something interesting happens. As intelligence becomes cheap and abundant, perfection becomes cheap too. And suddenly the things we used to hide, our imperfections, our rough edges, the small inconsistencies, laziness that we think and that every work we do appears in, well, they will start to matter more, because that's the only signal left that something was made by a human being. AI can generate something flawless, but it cannot replicate what it feels like to be you. Those errors, those wrong those wrong thoughts that you get in mind, or anything that is not perfect, well, AI cannot do generate that. And maybe that's when the shift happens. Not a world where humans stop creating, but a world where human touch becomes the most valuable part of creations. Those imperfections that we envy may finally be the biggest asset that we have in the world of AI. And people are losing those assets at an enormous rate, because research showed that adults who use AI of course lose the skills, but children who use AI for any kind of task from their birth will never gain those skills. And that's an important thought to sit with. What do you think will happen in the future? Tell me about that in the comments. Consider subscribing, and if you have any other idea to make a YouTube video on, tell me in the comments. Bye bye.